Code. We're the good guys now.
Code. I guess we are.
Code, this video is going to have some advanced topics that you don't necessarily need to know. Code, you can skip it if you want, but learning how to do this actually does have some teaching advantage, so even though we used to have a homework that asked you to do this and I took that out, there's still value in having you see in a video how it's done. I want to show you how to make your own data. In order to do that, there's 5 things you need to specify. First off, the sample size. How large of a data set do you want? Also, you need to specify the standard error. How far from the regression line can the data go? You need to have a beta naught, that's your intercept, and a beta 1, that's your slope. And then we need to specify the x values. And I'm going to say my x values are size of the fish. And I'm going to give the x values 0 up to, let's see if this is inches, 8-inch fish? That seems like a pretty big fish. How many of these x values? How about n of them? What this says is I want to create x values that go from 0 up to 8. And because I said I wanted 1,000 of them, there's 1,000 data points, and it's even increments all the way from 0 all the way up to 8. That's not the only way to do this. We could also specify size by saying I want random data that's uniformly distributed between 0 and 8. That way they won't be all nicely spaced out. Or we could specify it to be normally distributed, an average of 4, standard deviation of 2. I guess we'd have to worry about possible negatives because the normal distribution doesn't care about that. It doesn't really matter where your x's came from, so I'm going to stick with that first example simply because the sequence command is something you've seen before. And then I'm going to skip a line. So there's stuff that needs to go right here, but I want to explain why. This is the size of the fish and how long it can live outside of water. How long can a fish live? I don't know what's realistic, but let's see what we get. Beta naught plus beta 1 times the size of the fish. If I run this, I have x values called size, I have y values called live, and I can plot how long does a fish live based off its size. And I get that some fish can live 11, this must be seconds, live 11 seconds. Well, first off, does this look like realistic data? No, it looks like a prediction line because we used exactly the prediction line. There's no error. In other words, this S, this standard deviation, hasn't been a part of it. We don't have any residuals, so we need to add that in. How do I want these residuals? Our regression is based off the assumption that the residuals are normally distributed. We need 1 for each data point. It should have an average of 0. That means the dots are centered around the regression line. And then S for that standard error. If you're remembering the notation we used from the intro class, we used mu and sigma squared. That's not the notation for R. So this will give us randomized residuals. If we add those to our y values, then our y, that's way too much residuals. It goes all the way down to -40. So much residual that you can't even see the line anymore. So I'm going to back this down from 20. Plot it again, a little better. Maybe 0.2 for our S. Okay, so you can play with these numbers. What happens if I change n to be 10? Well, that's fewer dots. What happens if I change the beta 1 to be 0.3? The answer is it makes it a little more steep of a line. Of course, R is going to make the box fit around the data no matter how line the steep is. I mean how steep the line is. So this was at one point an assignment to go through and change these numbers and see how the regression line altered and changed. I realized that the goal of this class is to have you run regression, not make fake data. But this is still helpful to kind of get an idea for how the relationship is. So if you want, you can grab this code and play with it and make up your own data.